So let's start webinar about biomass boilers and how to optimize biomass boilers using digital twin technology. Today I would introduce general digital twin technology and examples how this technology is helping, assisting biomass operators, the head of boiler house and technical directors to operate and increase operation excellence. Time to time, probably I would focus on allowing participants to join our webinar. So sorry. And who we are, about energy advice, about digitalization maturity, why digitalization, what is a digital twin, cloud solution for the data collection and visualization using IoT, how digital twin technology can be used to increase efficiency within design limits, EA-SAS Boiler solution as a digital advisor for operators, indirect method of fuel consumption and moisture content evaluation, flue gas recirculation control and erosion effect reduction, boiler maintenance efficiency increase, human errors avoidance, and EA-SAS Boiler dashboard and report examples. Today we are going to look and discuss who we are. Energy advice company is based in Lithuania, Europe Union, and we are a company which provide consulting services and provide cloud solution for the energy intensive sector. And our goal is to increase efficiency and sustainability. We provide couple brands of a software. It's EAPSM, it's desktop version of a software for the hydraulic system analysis and electrical system analysis, also as EA-SAS solution, as a cloud solution for the digital twin technology implementation, for the data collection from IoT, real-time analysis, real-time calculation on Python, and in general digital twin solution. About digitalization maturity, if you are talking, basically the first step, of course, is microcontrollers, and microcontrollers control process according to the set points, and some SCADA visualization probably exists, as you know, and human can do impact to the process through changing set points. Probably higher maturity of digitalization would be if we add some general meters, for example, fuel weight, electricity, heat meters. Next maturity level would be multi-variable control, when we have quite sophisticated PID controllers, and most of the time humans do not make impact on the control. Last 5 to 10 years was monitoring system era, when we put a lot of smart meters everywhere and collect data everywhere, invested a lot of money to monitoring system. All data are in cloud, but raise question what to do next and how to do next. And here we are, it's digital twin technology. In general, with digital twin technology, we do mathematics of a physical system and incorporate live real-time data from a monitoring system. And this allows us to understand of an engineering system and better control. Finally, it is a reduction of fuel consumption, increase of efficiency, less human errors, and etc. So it's general rule of digitalization. In all these cases, you can calculate return on investment from the microcontrollers, general purpose meters, multi-variable control, monitoring system. All of these investments to the digitalization or better automation control, better understanding of a process allow us have some ROI, better or less good return on investment. And finally, digital twin technology is here with its own ROI, which creates you extra efficiency, fuel accounting, fuel quality evaluation, prolong the time between maintenance and predictive maintenance in general. So why digitalization? Why we need this? Because data probably needs to be accessible from anywhere. Why we use cloud solution? Because we would like to have less expenses on IT infrastructure and access data from everywhere. Some data is missing. We have always data blind spots because of expensive metering. Probably we can add flow meter, for example, air flow meter, flue gas flow meter, but finally these flow meters would have metering error and they would be expensive and probably create for us more problems when it creates value. Already we have a lot of data. But all this data finally do not create value, and we are still looking for some solution. For example, if you're talking just about a digital twin of a biomass boiler, we have SCADA control system and have a huge amount of data: flue gas temperature, pressure, flue gas air pressure, variable frequency, direct frequency, temperatures, economizers, water, steam, and etc. So a huge amount of data. And if you have this data, we still face issues during the operation of a boiler. For example, thermal load dynamic. Thermal load change over the time, faster or slower, different applications, different industry face different dynamics, but finally it's dynamic. It's thermal load is changing, steam consumption change or water flow is changing, etc. So fuel calorific value change. Finally, water, if fuel could be like fixed, but water content in the fuel could vary, and this creates absolutely different conditions inside the boiler to operate on, and operators know this situation because less water, fuel dry faster and burn faster. With higher water content, fuel dries slower and burns slower. So all parameters, all set points, in fact, inside the furnace changing, and the question is how fast and how good multi-variable control or just microcontrollers program inside is capable to adapt to changing situation. And finally, when we operate the boiler, residue formate on the fire tube, on furnace wall, and all of these changes inside the boiler, in fact, change the characteristic, heat exchange, thermal conductivity, hydraulic losses coefficients changing, and due to this change, finally you should do some adaptations to the boiler set points. Flue gas temperature fluctuation, also one of the trigger which affect our behavior, and grade rate flue gas recirculation set points also change, and because of these changes, our operators behave in one or another way, and this make impact on final KPIs of operation. So what is this digital twin? And from the description from Wikipedia, we can understand that it is the collection of digital data and modeling representing a physical object. If we have boiler physical object, we have mathematical model of a boiler. So we have a digital copy of the engineering system. It is absolutely different from the SCADA microcontroller or multivariable control, because inside it is just loops, control loops, and in fact no mathematics in controllers, but the digital twin in fact describes mathematically behavior of a biomass boiler. It is another description, it's digital copy of physical system and perform in real time. It's very interesting that mathematics performs in real time. Or another description, it is real-time digital replica of physical device. It's almost free description about the same. It's real-time mathematical copy in general. People asking us, are we going to install another controllers? Are we going to change existing controllers to another controllers? Answer is no. You have existing controllers, and these controllers is enough to perform boiler control, but we install data collection software. It's like OPC software, OPC server next to your boiler SCADA, and we collect data in each minute in real time. Collect data from your SCADA system, and if you have extra metering devices, we collect data from extra metering devices and send each minute all this data to the cloud. And all this data in the cloud is together with mathematics, and mathematics is calculating conditions, what's happening inside the boiler. So if we come back to the cloud solution, so finally you can access everything from the process about your process through a web. Finally, very interesting that the solution is able to calculate biomass calorific value, capable calculate efficiency in real time, evaluate biomass calorific value and moisture content impact to the efficiency, and evaluate individual boiler components and conditions. Here you can see picture to access through web, and the example of a table where we put amount of fuel burn at calorific value, water content inside the fuel. It is very important not just to understand that something wrong or something could be improved in your boiler, but it's very important for operators to get optimum control set points, to understand how far the boiler is. So you get optimum control set points, and these set points could be and are delivered to the controllers set points. You have unlimited data history, PDF reporting, and biofuel mass accounting. It's also quite important question. Coming back to the case study, you can see the picture of a boiler, which is fuel supply grade, fire tube, flue gas ventilator, fan. It is fan recirculation, up top and bottom. It's just diagram showing here, and all this data live from the SCADA control system. And if we check how an EA-SAS software behave for the fire tube state advisor, we have issue, or our client have issue. It is not clear when to make the cleaning. and it's not clear where make cleaning. It is fire tube or it's furnace. Where is the problem? What to do? And how we behave? We calculate hydraulic losses coefficient from the furnace. From the furnace side till the flue gas fan. This route of a flue gas hydraulic losses coefficient is calculated, and we see this coefficient, and this coefficient indicates resistance along flue gas path. Another coefficient is logarithm temperature difference between water side and the flue gas side is calculated, and thermal conductivity coefficient from the fire to the water side of fire tube is calculated as watts per degree or per Kelvin. So what is the benefit of that? Here we can see from the boiler operation from the September, where losses coefficient is hydraulic losses coefficient is in blue color, increasing, sorry, and thermal conductivity coefficient is almost at the same level. And here is the moment when the decision is to clean boiler decision, and boiler was cleaned. And from a thermal conductivity, we see that the problem there was no problem. In fact, it's almost even better thermal conductivity, but hydraulic losses coefficient were increasing, and the decision was made only to clean fire tube side, so the client saved time for the cleaning, because the furnace was not cooled down till the temperatures where we can human enter inside. It is only fire tube side, and after cleaning, the hydraulic losses coefficient was increased almost to the level from the good condition of a boiler. A little bit losses still exist higher, but because due to probably furnace condition. Another case where digital twin allow us to calculate things which we are not capable to measure, or measurements are too expensive. For example, where is no flue gas heat consumption meter. We have flue gas consumer, but we don't have an energy meter. But of course, here was installed flue gas flow meter, but due to dynamic, it was not capable to calculate correctly. But what we have variable frequency drive and fan and electric power metering and fan characteristic and pressure difference between before and after the fan. And from the regular frequency drive measurements, flue gas flow was evaluated. And because we understand flue gas density and enthalpy, we were capable of calculate real-time online heat consumption. So it's from the furnace, flue gas is coming, heat exchanger, some recirculation for the temperature control, and flue gas output. So energy consumption on the flue gas consumer were calculated in real time, and no additional flow meter is required. Flue gas condensing economizer. You can see here a single line diagram. All part of data here inside is metering value from the SCADA system, and another part of the data is from the calculated value in real time, each 5 minutes. And here we see a flue gas condensing economizer. Input flue gas temperature, flue gas its temperature 157, output temperature free it's 46 degrees, water temperature input 43, output 48, and mass flow, water flow, and it's very important to monitor ratio of flue gas condensing economizer production ratio with the boiler production ratio, because condensing economizer is designed at assuming some fuel, water content, and thermal capacity ratio. And the target is to keep the ratio at the maximum or even higher than the maximum if water content in the fuel is higher than designed value. So in fact, if we have target 22-23% of ratio, and we have less capacity, and if we have higher water rate in fuel, probably we can reach a higher rate of heat production in condensing flue gas condensing economizer. And additionally, we calculate logarithmic temperature difference between water and flue gas, and thermal conductivity coefficient, which all of them allow us to predict the condition of the economizer, and this prediction allow us to understand where the cleaning should be performed. Additionally, pH meter is installed here also, and in addition, dew point temperature we also can calculate to understand why dew point is interesting, but we should understand how far the flue gas output temperature is from the dew point temperature. It's like a gap between the capability to condense water from the flue gas and real condensing situation. Flue gas recirculation, yes, it's also here we have fun. It's electricity meter, because it's variable frequency drive installed. So we have electricity consumption, we have variable frequency drive frequency or in percentage frequency, and it's very important to understand how much flue gas in tons were circulated inside the boiler. Why it's interesting and it's important? Because of fuel drying process, flue gas temperature control before the fire tube, and surplus flue gas recirculation leads to fire tube erosion. So, but a very interesting question is that if we have fun characteristic, we have electricity consumption and frequency of output from the variable frequency drive, we're capable to estimate efficiency of fun, mass flow, and delta pressure on the fan. So we're capable with extra metering of the pressure after the fan. We are capable to understand the pressure inside the road of flue gas. Coming to the next slide is about the temperature, and usually temperature, as you can see, another example real from our boiler, EA-SAS boiler solution, that you can have extra metering flue gas temperature inside the boiler, but some of meter could fail and show you lower temperature in fact exists. And for example, here we have 4 meters, and 3 meters show less temperature when 900, it's 830, 780 degrees, and one sensor is still showing 1076, and estimate from mathematics, from boiler mathematics estimated temperature show that it's near to 1075 temperature degrees. So you can see here trend how the temperature metering and the temperature flue gas temperature calculation behave in dynamics. And you can see it's quite well behave in dynamics. And also we collect historical, for the predictive maintenance, historical chart trend of distribution of temperature of flue gas inside the fire tube. So, and why it is important? Because of fire tube erosion effect. Because if we have over temperature, we probably would face some erosion effects. If we have trend and all conditions inside the boilers, we can extrapolate this and predict what would be in the future, how efficiency deteriorate in the future, and when to make a decision to do something with this. Our technological benefit is that we can in real time calculate water content inside biomass fuel. And as you can see here, it's during from 1 day. Yes, it's from October 11th till October 12th. You can see that water content in the fuel is changing. And even here we see drying process where we probably reduced capacity, boiler capacity leads to reduction of fuel supply and drying of the fuel. So in fact, in this situation was fuel drying process, absolutely different behavior of a boiler. And here probably the capacity, thermal capacity was increased and extra fuel was added to the boiler, and you can see it's increased calculated water content inside fuel and flue gas. So calculating water content in flue gas, we are capable to calculate and fuel mass, which is consumed or burned in boiler inside. A lot of discussions about the corrosion and erosion, and where is the problem, where is the reason, how to do, what to do with this erosion and corrosion. We should come back to theory about corrosion and erosion, and what does it mean, corrosion? Corrosion is gradual destruction of materials by chemical or electrochemical reaction in their environment. And probably inside the boiler we don't have electrochemical issues, don't have electrical potential because of perfect grounding everywhere, but we have chemical corrosion, and this could be divided to pitting, chloride, sulfur, weld decay, high temperature impact on tubes. It depends on tube material, also the speed, and fuel ash covered tubes at high temperature. Here we can see that corrosion rate highly depends on the temperature and on the material. And here we see that, for example, if we put additional nickel percentage to the steel pipe, we would have higher corrosion at lower temperature, or vice versa. And erosion effect is a process of in which materials are removed from solid surface by action of solid particles impinging on it. So it's erosion, it's like a mechanical action, and it depends on the particle size and flue gas velocity, and this parameter is controllable because particle size depend on the fuel burning conditions, how good the fuel was burned, and flue gas velocity depends on mass of flue gas from the fuel and mass of flue gas from the circulation. So, and of course, erosion depends on the collision angle and surface hardness, but we cannot control this, we cannot make any impact on this. So fuel content cannot be controlled, how flue gas temperature could be controlled. So sometimes people claim that the fuel is bad and we cannot do nothing on this, but finally flue gas we can control, and ratio of flue gas recirculation, we can also make impact. I had a question from Chris, probably I can answer because I finished here. The use of digital twins is increasingly important to deliver high efficiency HVAC installations. You are focusing on generation efficiency here, but are you using digital twins in any way to access hydraulic efficiency of the wider installation? Efficiency gains from looking at the complete system can be huge compared to just looking at the generation plant alone. Yes, yes, your question is right. We have a lot of examples of digital twins of overall solution, and probably if you're interested for more detailed presentation on how industry could be beneficial from digital twin, we had historically we had already webinars on this, and here we are focusing only to the description of part of our technology and only to one application, and trying to describe deep from inside how it behaves. But yes, we have examples for the overall industrial digital twin. Thank you for your question. And so erosion and corrosion, probably when we look at the distribution of this long time high temperature, it's temperature impact, it's flue gas recirculation and fuel supply control. Ash corrosion, yes, this is related only to the fuel. Welding failures probably would be related not only to welding condition, but also to the temperature and dynamic in general, hydraulic dynamic. Short time temperature, yes, it's still temperature. Erosion, it's still high rate of mass flow, and oxygen pitting and cracking. Probably it's also would be really true corrosion effects. So, but when we calculate everything, summarize everything, probably erosion effect would be more important in comparison with corrosion effect, and the corrosion effect, yes, we can only control through flue gas dew point temperature for each component of the content which creates corrosion effect. So dew point, yes, if we for the water dew point, it's very easy to calculate because we calculate water content inside flue gas. It is a little bit tricky to calculate dew point of another gases which condense, because you never know during the burning process. You never know what is content or amount of this sulfur and chlorine inside, so you never know. And because you never know, in fact, it's very tricky to just to calculate dew point, because it would be just like an indicator, but in fact don't create value. When we do smart control of the boiler, it's also we can in very short term we can forecast. We can make real forecast. We do real forecast of the boiler loading, thermal loading. And why it is important? Because boiler has fuel burning inertia. So if you increase thermal capacity, we dramatically increase, we should put extra fuel, but it has inertia. And if thermal load increase, it leads to reduction of the temperatures and probably coming near to dew point. of these bad gases, and or if you have pressure system to the reduction of the pressure of a steam. And if thermal load decreases, it leads to temperature and pressure increase. So forecast for some half an hour extent allow us to better control and to avoid adding surplus fuel or avoiding to add extra high temperature, where the automation is trying to reduce this temperature and ventilate the boiler with a flue gas recirculation or surplus extra air supply. So coming back to boilers in general, digital twin solution is capable to provide you set points for our fuel amount supply, primary, secondary rate, furnace grade rate, flue gas recirculation. So it's in general, it's not just the monitoring and collection data and building mathematics with KPIs and with some predictive maintenance elements, but probably it's also for the operators. It's a set point where you can where operators can track these set points. Coming back in general, what we mentioned before, that flue gas temperature and temperature at furnace boiler operation status indicator. So if you have fluctuating temperature, and probably we have and fluctuating recirculation, we have unstable fuel supply. If we should regulate quite often grade rates, that means that fuel water content changes, but also flue gas recirculation and drying process is not stable, and automation is not capable to stabilize this. And so surplus air supply to furnace, increased temperature at furnace and amount oxygen in flue gas, and fuel surplus reduce boiler efficiency. And finally, lifetime of a boiler, mentioned everything here. Lifetime of a boiler is evaluated not by produced heat or fuel combusted, but increased efficiency for long time periods between maintenance. So in fact, we should take care about the amount of fuel burned instead of amount of heat produced inside the boiler. And our solution, in fact, it's not only solution for the head of the boiler houses, but also it is assistant for the operators, more or less, because we provide set points. And finally, you have the solution efficiency control, data storage, predictive maintenance, and forecast. What problems can we solve if operation quality depends highly on person? So if you should rely much on the person who operate the boilers, and it's a problem. So we can be beneficial for you. You are not sure about the boiler efficiency. Your boiler efficiency is not stable, looking to the numbers from the past couple of years, and you would like to decrease maintenance cost. And how we install, how we process with digital twin, this diagram is in general for any digital twin we are providing to our clients. It is first data collection. When we get all data from your boiler about, for example, ventilators, air, flue gas, recirculation, pumps, furnace grade, dimensions, rates, speed, fire tube, side, economizer side, all this data we should get and digitalize. I mean, we need to have characteristics, and it's value for you when we do this collection. We collect data from your controllers two ways. One way is from the controllers directly. Another way is from the SCADA SQL database. And if you have extra smart metering device or some whatever, we collect data from the smart meters also and build digital model, and this digital model is ready for you, and you are buying finally not like a cloud, but you are buying a service where you and your boiler house operators are capable to use set points, to use data, to use insights what we are delivering. And dashboards are configurable dashboards according to your needs, but in general, it's at least boiler efficiency, at least economizer, components efficiency, biomass consumption, cost of electricity, energy, prime cost in euro, in megawatt hours, in access ratio. Even though if you provide task control, set point task, it is different between real value and provided optimum value, and these reports saved in database, and you get through email about what is going with you and with our solution, how it's increasing, how efficiency is increasing in comparison of previous data. And who is a user? It's operator, head, and technical manager. On all of you are beneficial: operator real-time set points, optimum set points, head, boiler house statistic, how operators were successful to operate, and technical manager for the decision making of predictive maintenance. And in fact, it's capable, system capable to reduce human errors, optimize efficiency, increase personal productivity, and reduce maintenance costs through increased time between the cleaning, between the maintenance activity. Of course, some examples also we have extra. It's 20 megawatt steam boiler with wood chip. Data collector software was installed. High dispersion findings prior to the project is the high dispersion of a fuel and efficiency, bad accounting, efficiency increase with higher heat load, and it's not good. Efficiency increase with a high heat load. Reason was maintenance before heating season, bad boiler performance or minimum load, but if we found that efficiency increase through and with high dispersion increase through heat production increase, so finally we did like it should be, that efficiency decrease till some minimum on the highest load, thermal load, and increase up with a lower load. So the curve from the like this was created as two curve how it should be. More complicated or boiler with more components, it's furnace, thermal oil, economizer, flue gas, consumer, filters, condensing economizer, chimney, and flue gas fan, ventilator, and extra air heaters, and fuel silo. All of these for 30 megawatt steam boiler was installed, and the idea was to calculate fuel consumption. Target of the project was absolutely different. The targets I described at you in this webinar. The target was just to calculate fuel consumption and silo level. You can see here silo level is changing, and here you see calculated biomass from the all solution inside here. And yes, of course, some reference we have. Solution is installed and ready to install your application. So thank you. for your attention. I finished with my slides and waiting for your questions.